Okay, we are live. Hello. Notifications blowing up on here. What the heck is this? Heck? Academia is a crazy place. Silly autocorrect. This is not. This is like completely disrespectful. That's a bit much. Morning. That's ridiculous. You can't just slap safety on a subfield that's really constrained optimization and then claim the moral high ground. That's just not how this works. See anything else on this? More Pokemon stuff. Let me go see if we have any more Pokemon stuff or if I should just... Let me just double check. Okay, I guess it's on me to tweet out additional stuff on Pokemon. This is cool. I miss anybody? I don't think so. Just drafting this, and then we'll do some dev. Okay, that's good. Twitter's been popping here. Oops. No, I am skeptical of this. I'm very skeptical of this. I don't get this, like, this take here. I mean, I know Jap is good, but, like, I don't... Like, you can't demonstrate these methods on, like, really small academic tasks and then just claim that they'll solve everything. That's disrespectful. Because he does a lot of good stuff. I didn't mean it that way. That heck's really hard. Like, I don't trust any, like, Go Explore is a method that just seems to make a lot of sense. But, like, I don't trust methods just because they seem to make a lot of sense if they haven't been demonstrated on, something much bigger. Gotta love the bots. Okay. So, we have stuff to do. Okay. So we have a lot of points right around 110 seconds. It looks like. There's something about this, right? I assume with the parameters. So let me think what we want to do today. There's quite a bit of stuff to look at. Let me double check one thing. Because there are two different directions we could take for now. Okay, that's taken care of. Cool. I really want to get this algorithm into a decent spot. Oh yeah, I think I forgot one message. Where did it go? I think that what we're gonna do right now is we're gonna decide based on what this result tells me. So I think if I just filter, do I have this? $150. Okay. So here are the runs for this. Learning rate, pretty robust. Gamma shouldn't matter because it's P3O. Lambda shouldn't matter, right? Yeah, it doesn't matter. Almost all just one update epoch. Okay. Pareto front. Here. Oh, most of these are at 150. Yeah, most of these are at 150. So some of these are much faster than others for some reason. It's got to be mini batches or something, right? They all have 1024Ms. They all have the same batch size. And there it is, mini batch size. So why is this so slow? It's just like, let me think about this. There are a couple things here that I have ideas for. Can I find the baseline that we trained in here? Puffer breakout fast. Okay, this should be good, right? There we go. Yeah, so here's the big difference, right? This algorithm is able to train with a mini batch size of 8192. I believe this is the difference, right? Oh, there are also some with 2048Ms as well. But if I'm looking at differences, that's the biggest one I see. There's a lot of 1 epochs right here. So the biggest update is that for whatever reason, GAE works with bigger mini batches and more M's. Why would that be the case? What is it about the algorithm itself? Hold on, it could just be total time steps, right? Maybe I'm shooting myself in the foot by making this the max. Look at this. What are we at total time steps wise? Yeah, we're pretty much pressing up against the maximum here, aren't we? So maybe if I increase total time steps, and maybe if I increase the maximum total time steps, it would find faster parameters for solving. Does that make sense? Let's assume, okay, here's an idea. If we assume that there is a small difference in sample efficiency, even if it's initial sample efficiency, because our methods are a bit different, right? So let's say that my method takes, 20 million more samples to optimize. Is that consistent? I could see that being consistent. Because, these ones could be slower over here, okay? So if mine takes 20 million steps more to optimize, and you're not allowing it to get those additional 20 million steps, which should just take 20% more compute, it could have to go to fewer M's and smaller mini batches, which could be a much bigger than 20% performance penalty. Would that make sense? I think it does. I think that makes sense. I mean, what other parameters are there here? 1 update epoch, 32 horizon. Can we just do this for a second? And just see like what this thing finds. It does get mini batch of 4096. It really doesn't try very hard. Over here, does it? It just didn't try. I wonder why not. Got good results over here. Maybe it had to adjust different things in order to make that fast enough, though. I don't know. It's a time steps problem, right? What else do we have here? Nums. Yeah, missing. Oh no, you know, it is starting to do some stuff. 2000 here. Maybe it just takes it a while. These aren't that different, really. Ryzen to 32. 16, yeah, whatever, they both work. One update epoch for the most part, with a couple exceptions. Value coef. That's pretty similar, right? It's stable, same with max grad norm. Well, max grad norm goes, we have a much wider range for max grad norm, which is interesting. We have a different loss function, though. Gamma doesn't matter, lambda doesn't matter. Entropy coefficient. You kind of get a big stable range. Is the learning rate different? That's what I'm curious about. 002. And here you have 002, but it also goes all the way to up to 0.01. 005. It's off by maybe a factor of 2 from there. I wouldn't call these ranges way too different. And then the Pareto front is very, very similar. This is so close. And it really just seems like it's there is still like a 10% speed difference, right? So with that, they're not that far apart. And also there's another 30 runs to go here as well. Well, hang on, right? If you have an algorithm with more hyperparameters, you're pretty much always going to be able to get it to be slightly faster, right? In terms of total time steps, if they're reasonable hypers. Because each of those is tunable and gives you an inductive bias on the environment that you have to learn from scratch otherwise. So this is kind of fine for there to be a tiny perf gap. I think that we should be pretty happy with this. And instead of trying to close this last little 10%, which will probably go away eventually anyways, maybe it'll get like slimmed at least, we should probably think about some of the larger issues with this. Yeah. So I think what we should do is we should just like kind of say, okay, these are very close. You don't have to beat the perf of PPO in terms of samples or in terms of like wall clock. No, in terms of samples should be similar. In terms of wall clock on an environment for which you've heavily tuned the parameters for the baseline. You just need to about match it. And then you need to demonstrate that it can learn things that PPO can't on the harder environments. That would be the test of this more than anything. Yeah, that makes sense. Okay. So if we're going to say that, then the main thing is figuring out why this doesn't play nice with longer horizons. Yeah, with longer horizons. Let's take one of these params that seems good. 22054. One of the earliest runs. Oh, this one only ran 79 mil. It's probably a lucky run. It looks very clean, but it's probably a lucky run. I might just kill the container by mistake. That's fine. So, new parameters here. This is 66 million steps is what this took to solve. Right there. So we'll give it a few additional, I don't know what that's doing. We'll give it the full 80 just to give it a little bit of wiggle room in case there's variance. We'll do total 80 mil. Where'd it go? $1024Ms. Batch size 2048. Yeah, this is a way smaller mini batch size. So this is why it's going to be slower. It does seem like the max grad norm param changes quite substantially. Gets to be a much wider spread. Then we do VF coefficient. Forget any update epochs? Is it multiple? Where is this? One update epoch. Okay, so we have batch size, epoch, entropy. Don't need gamma lambda anymore, which is great. Learning rate. I only forgot the most important parameter. That's a funny recommendation. Grad norm. Cool. I think this is good. Comment all these. I just want something decent, to work off of. Oops, I don't know what I'm doing. Remind me back. Okay. List index out of range. Lovely. Gotta love container driver detaching for no reason. This is bullshit. MIT professor being kind of rude to Richard Sutton in a very silly way, and then went on a big long thread about it. You can't make a thread here. What do we think on this? Actually, no, it's worse than that. Right? Is it just me, or does the Minecraft Diamonds thing actually look very simple in comparison to this? Because look, if you're getting diamond in general and you're like gonna do it through exploration or whatever, sure. If you're gonna like go caving, that's kind of interesting. But I'd still nowhere near Pokemon even if you do that. And that's not what these models do. They just dig down and hope they get lucky. I don't even think that they dig down 2x2. They just YOLO it and say if I hit lava, I hit lava. I disagree with this. Oops. Stupid autocorrect. Lucky trajectories. It's also possible. Well, I guess this doesn't apply as well, right? No, that would be multi-seed. I don't even know if you need different seeds. Robotics doesn't really have seeds in the same way. Why behavioral cloning? Guess today's a common Twitter day. I think RL is one of the better ones for open source, isn't it? This doesn't make sense to me either. Field is valued. I don't understand. Like, these are two different things. Like, I don't even know what the heck to say. This is just like a Byzantine. Slow down the. I don't even think self-driving uses RL. I'm convinced this guy. Are there even any of these where there's been like an irresponsible deployment? I don't know of any. Why? Can you explain to me why the Twitter auto checker doesn't like? It's like gaslighting me into thinking I can't spell. Stupid thing. Maybe it's the OS. I don't know. What's on the docket today? I don't know. There's a lot of random stuff on Twitter that keeps distracting me. I mean, to be fair, stuff's doing pretty well. This is the new post from today. I just did this. It's already at 48. I'm just gonna keep posting stuff every day with the with different graphics, and then hopefully it transfers over. He's at 180 already. It's pretty good, right? How'd this do? This finished a long time ago. This did not do. Wait, what? Where'd it go? Oh, hang on. Uh, Rain dot. Yeah, these hypers are just slow because the mini batches are too small, right? There's too much overhead in learn. Mainly in learn. Learn and forward, maybe. Oops, where'd this go? Why is this like nowhere close to the original? Huge blog on Pokemon Red. Congrats to the group. Didn't get close to 50K views. I don't know. How can you see the blog post views? Because it was also on Hacker News. I can see my post on it and the original. 15K on the retweet. Oh yeah, 40K on the original. Very nice. Yeah, this did pretty well. Yeah, 40K on the original, 15 on my retweet of it. And I mean, we're not done yet. We're gonna keep posting stuff. So this didn't work at all. I assume I must have mucked up the parameters or something, right? Wait, what? What happened here? Oh, I probably grabbed one from the wrong list, right? Unless I messed this up massively as well. That would actually be really funny if I messed this up massively. Let me see. Burrito. $22,197. Let's do that one. Use P30 is true, right? 100K time, 100 mil time steps. BPT. Entropy. Mini batch. 4096 mini batch is better. I wonder if it's going to compensate with 2 update epochs. No, it's 1 update epoch. Okay, maybe there's something here. Good luck. We'll be tuning in. Yeah, I'm going to be probably deving all day on Saturday. I have, well, we'll see where I go today, but I have some algorithm dev plans for Saturday. There's also some new research that I want to get started on. Lot to do on Puffer these days. Lots to do. It's a busy time. Hey, welcome. Let's see if this one trains. Okay, Pokemon stuff still doing well. Alright, that's better. That is better at least. Was it solve? I mean, it would have to... Oh, yeah, there it goes. Solve's right at the end, which is kind of funny. It, like, needs that last little update, I guess. Weird how that works. Cool. 56, yeah, this matches nicely. 120 seconds, but I gave it some extra steps to account for seed to seed variance. Okay, it is 1:30. I've gotten super distracted by all this mess. What I'm going to do is I'm just going to close Twitter. I'm going to take a minute, go use the restroom, clear my head. I've been kind of like babysitting all these posts and stuff, the engagement, because there are some cool people responding to stuff as well. And now that we have a good baseline with the new algorithm that is relatively fast, we are going to use this as a launch point for exploring the one main issue I have with this algorithm at the moment, which is there's this horizon that you define that is not supposed to be a hyperparameter, but kind of works as a hyperparameter at the moment because of some quirks. I think the same thing. There are some potential issues even with our PPO implementation because of this. So essentially, this is something that has a high chance of resulting in a general improvement to PufferLib overall, and then B, making this algorithm actually work way better in the way that we would expect it to. We'll do some analysis on that. But yeah, take in 2 minutes. I'll be right back. Okay, we are back. Phone goes over there. No more. We've done enough on X for now. Let's get some real work done. Now it will be tricky. So I think that the main issue. Well, yeah. Before we P30 Horizon. I want to just double check to make sure this actually doesn't just work. I don't think it does. Come on. Where's the new run? There it is. Yeah, so this is going to take way longer here, right? I think that the main issue with this, maybe I should elaborate a little bit. Right now, when you train this new algorithm, it requires a horizon parameter that tells you how many time steps ahead to look. Now you actually get to choose or learn how much you pay attention to those time steps, each of those time steps, which is the important part. So really what this parameter is supposed to be is just like a compute budget parameter, where it shouldn't even be that expensive to look farther ahead, but you know, it's a little bit, it adds a little bit of overhead. Now in practice, what's happening is it just doesn't learn properly when you set it longer. And I think, let me make sure that this makes sense. I think that the reason it doesn't learn, we have, how many M's here? Let's see. 1,024 environments. And a batch size of 100, so it's 128 steps per environment that are in the rollouts. So if we assume that the environments take longer than 128 steps, which they mostly do, you can see at the episode length, then when you compute the value for like the last 127 steps, you're actually going to be pulling data in from the next environment by accident, which you don't want. So I think that that is what is happening here, is that you're pulling in data from environments that you shouldn't be looking at because we can't separate boundary conditions the way we want to. Mind you, it still actually learns, just doesn't learn anywhere near as well. Okay, so is there an easy way to confirm this? I don't think so. I don't think so. I think we have to update the kernel, which is annoying. How do we update it? I guess it would just be there's going to be a little bit of fiddly algorithm development for the next bit here, but it's going to be important. this could be the thing that makes this algorithm what it's supposed to be. I just need to make sure I get it right. Taking different environment actions. It's not that it's taking different environment actions. So this is in the computation of the advantage function. Normally when you compute an advantage function, you start at the last time step you have from each environment, and then you roll it backwards. But what happens here is that you've collected trajectories for a lot of different environments, and you haven't gotten the done signals from them yet. So they're just in the buffer partially completed. And since there's no stop at the end of them, which it's kind of hard to add a stop in this situation, it's going to use information from the next environment to compute the advantage, and that gives you a wrong calculation. This effect is mitigated in generalized advantage estimation somewhat, but it's going to be much more important in this algorithm. To be fair, maybe it affects generalized advantage estimation as well. Maybe our PPO just gets better from this too, which would be fine. Which would be fine. But yeah, I think what we're going to do is we're going to have to pass sort keys. Because this sort keys thing it's kind of tricky to calculate those bounds, honestly. Kind of tricky. You can't wait for the buffer to complete. It doesn't work that way. The buffer just stores all of the data flat. I mean, well, maybe you can. Maybe I'm being a little bit too dismissive. Let me think. I don't know how you would. The thing is, you also wouldn't necessarily want to, because you have to wait for the M's to finish. You can't do full environment rollouts, right? Some environments just take a very long time to run. So you do need to have environment segments. And this is basically, there's no cap on the end of the segment. It's kind of hard to add a cap. But I have a way of doing it at the moment. I just have to figure out. It involves a little bit of fiddly index checking, and then I have to actually do this fiddly index checking in CUDA, which is annoying. But if I can figure out, maybe it's not that bad if I can figure this out. Well, hang on, I don't have, this just returns the indices. That's rough. I think you sort by n by d and then by time step, right? It'd be so much easier to just add, like you have a truncated signal for this, don't you? Like, wouldn't it be so much easier to just add a truncated signal here? I mean, I can technically do it here as a hack and then implement it more generally if it works. That might do it. Maybe extend compute time when the buffer finishes. Extend compute time. I don't know how you do that. The problem's kind of like, it's not that you need more data than you have, it's just that you need to know when to stop with the data that you do have. You're basically overrunning the buffer. So this doesn't work generally because you have asynchronous environments, But I think that in this case, I might have a quick hack if I can just do, hang on. D plus T. How do you not log? You do log D here because you don't handle truncateds at all. Okay. I think I have a way to hack it for now that will let me run my experiments and see if this actually matters. Define the number of steps if you want it to work. Want to work as intended. So don't mind. Yeah, so it's a little fiddly because the thing is, in the general case, you have environments that are running at different speeds. And you basically just get a bunch of flat data that you don't have any way to organize until you have all of it. But then when you have all of it, right, each environment, maybe you've collected some full episodes, but then each environment has a piece at the end that kind of hangs off, and you don't have any way of telling that. I mean, like, I have the general purpose way of fixing this is to fiddle with the indices and propagate that change into CUDA, and then the issue should be fixed. But before then, it's a little hard. I say 1024. 1024. So let's do it this way. Experience pointer batch size minus you can't do that, so I gotta do, we'll just hard code D. Okay. Okay, let's see what this does for comparison. Yeah, if this is not going to be like an instantaneous fix, Huh? Hang on. Oh no, it's pretty darn close to the original curve. We'll see if it breaks away if there's like a big difference. Maybe this is not the issue though. We'll see. This could totally also be a normalization issue, couldn't it? Let's go look at that. How do we compute stuff? Oh wait, actually, I think I might know. Let me see. Advantage. Yeah, so the advantage is we make those sum to 1. But we don't bother with the other loss, making that sum to 1. Okay, hang on. So how do we test that? I guess what we do is V loss Okay, so this actually does do better. I don't know if it's significantly better, but we will see. The next thing I want to try is this, in which we mask the value loss. And we'll see what this does. Essentially, this would say that, hey, the problem is not in the advantage function. The problem's right here, if this worked. Oh, this is worse. How's that possible, right? Did I mess something up? Shouldn't be possible for this to be worse. Okay, it catches back up. It has a weird curve, though. Very weird curve. Yeah, these are still definitely different. I'm gonna run it again just because there's crazy seed variance in RL sometimes, but I'm guessing. Interesting. So we should probably check to make sure that the original still works under this condition, right? So I can't think of why else this doesn't work. Unless I've messed up the indexing, which would be hilarious in its own way. But looking at this, the curves are actually relatively consistent. The curves are relatively consistent. Is it actually possible I've messed up the ordering of this? That would be really out there. Okay. We'll try this as a baseline. Whoops, not this one. Hold on. Okay, we'll let that run. Buffer size. It's not that anymore. There's something else weird going on that we have to figure out. Reply to this guy real quick. What I'll do it here. This one makes more sense. it drives me nuts because the thing is, it's not that these things aren't important. It's that in the context that they were brought up, they're completely irrelevant. Oops, let's get rid of that bot. Stupid thing. Victorious, yeah, great username. Rid of that. Yeah. Preprint. Where's the blog? And the funny thing about this is that all this conversation does is like reinforces that a lot of safety research are just very unserious people. It's like mandate of heaven must do safety in all things, even where safety is not even remotely a concern. Okay, so this original here, this still works. So that's very interesting, right? This original here Still pretty well works. Yeah, this is about the same as before. Don't want their internal data. This, again, it's not what this is. I mean, this is literally Godfather of RL giving his opinion on like what directions are promising or not if you want to understand intelligence. And it's like, yeah, I don't think safety is particular, like safety or privacy are particularly relevant here. And it's like, but this is morally distasteful that you haven't considered safety and privacy in not deploying AI, but in sitting in your lab doing algorithms research. I mean, this is like, but you in your lab, did you think of the children in Africa while you were doing that? It's like, okay, maybe I thought about them another time, but now, not now specifically, because there's no relevance whatsoever, right? It's just like, this is the problem that you see, though, with a lot of the safety folks, is it's just moral grandstanding where it's completely unjustified. A lot of the times it's like, yeah, you're also sitting in your lab writing algorithms, but you're being holier than thou about it and insulting other researchers. Ridiculous. I mean, that was at least the most respectful conversation I've had with somebody in safety, so I'll give it that. It's just a Byzantine argument to me, though. It's a Byzantine argument, probably to slow down progress. Now, if we want to get on moral high ground, that I cannot accept, because we're building tech that genuinely improves a lot of stuff. And this will get into medicine. This will get into a ton of really important areas. That's why I get up in the morning. All right? So slowing down progress, no. No quarter given. I don't know. There are a lot of like really crazy ideas on these topics as well that are like mainly SF bros being very, very, very out of touch with reality. This wasn't that, to be fair. This was somewhat more down to earth, but still, there's like, it's just not getting through. Well, we have a clear-cut example here of what's going wrong. There are a couple possibilities, I guess. So let me think here. We get values mean, values standard deviation of indices here. And then we pass this in to the advantage function. Does this get done twice? I think it gets done twice, right? Those are the blocks we need to move past. Find this happening in government security a lot. Probably spoken a lot of them. Yeah. I mean, it's just like, the thing that drives me crazy is that like the thing that they say that they're worried about doesn't even make sense if you use their own arguments, right? They say like, we should slow down tech in order to make sure stuff is safe, right? And then they talk about like, doomer type stuff. It's like, well, okay, this doesn't even make sense from your perspective, because even if we were to suppose that the concerns that you're raising, which may or may not even hold any water, even if we assume you're 100% correct about everything, and like AI is going to destroy everything if we do it wrong, and like AI is going to get into all the bad applications and whatever, if you slow it down, China or another country is just going to do it first. Do you think they care about any of this stuff? No. No, they don't. So you're just guaranteeing that it's done, in the exact way that you don't want by slowing it down. That's all. It makes no sense to me at all. It's like a very, very weird academic perspective. Let me try one other thing. Can I even do this? Values mean. Think I can? Yeah, this will work. If I just do academic people, it is weird. Well, but the thing is, nobody's telling you that you have to expose, like, nobody's telling you that you have to, right? It's an invented concern. If you don't want to use tech that leaks data, don't use the tech. And also, like, privacy stuff going wrong is more like big supervised ML people, not RL people anyway, so it's moot. I haven't really seen anything like this in RL going wrong. We'll see what this does. If this doesn't work, then there's a data problem. If this doesn't work, then there should be a data problem. But the Pokemon stuff's doing pretty nice. Okay, so we shouldn't build gradient descent. That just doesn't make any sense. Yeah, it's very weird. Yeah, this is funny. I love it when he just sets me up for this. Thanks for the ad, Sam. Lots of assumptions without. Oh, the hack thing. Yeah, it's well. The other thing that's just like is kind of bullshitty here. So Tim is a Google DeepMind researcher, right? He runs a team at DeepMind. So like, yeah, they've got all the compute in the world to do whatever they want, and like armies of people on the internet who are gonna go run evaluations on their stuff because LLMs are currently the hot thing, right? But like the stuff we're doing, nobody else is doing, and like, there's a lot of potential that you're wrong, and that we're going to come up with some cool generalizable methods because we can run experiments in RL 1,000 times faster than the vast majority of researchers were ever able to run experiments in RL, right? You do 1,000 times more experiments, so you're going to uncover some cool stuff, probably. Um, so I don't know. It's like Tim what used to do like pure RL stuff and kind of just went all the way onto LLM train. I think that LLMs are currently taking too many resources away from the rest of research. Like, don't get me wrong, what's going on is kind of crazy with them, but they should take 80% of the resources from research, not 99% of the resources. Okay, perfect. So this is a clear-cut case of, unless I'm missing anything, I don't think I am. This is a clear-cut case. Something's just screwy right here. Okay, so B flat. Values mean. B values mean. There's no way this should be different. This should be identical to the previous. This is exciting though, because if there's actually a bug and it's already working this well, just a tactic to slow things down. They didn't have anything to say when LLMs are being trained. Now that they aren't post-training, I wouldn't say that so much. Because a lot of the LLM people, there are LLM people that are like legitimately just full steam ahead trying to make AI work, right? But the thing that they don't realize is the way to do that, like you don't need to crowd out the rest of AI. You already have all the resources, right? Like, I just like leave a couple scraps so we can investigate some other areas in case you're wrong, right? Do you know how much easier it would be to do what I'm doing right now with Puffer if I were doing this in 2018? like when RL was all the rage, we'd have like dozens and dozens of people building these environments. Like RL would actually be so far ahead. Heck, if OpenAI had just left their Dota team alone and let them keep doing some RL and keep pushing out some results, we'd be in a good place even now. It's just that like all the resources were drained out of RL, and it's fine. Like I'm fixing it now, but it's a heck of a lot of work, and it's a lot more work than it had to have been. Unfortunately, back in 2018, I was like a plucky 20-year-old who didn't have the engineering skills to do all of this, which is why I couldn't do it back then. But now I do have the skills, but okay, stuff's cooled down a little bit. So bad timing, but we'll get it working anyways. Damn. They compute for commercial purposes, yeah. Well, with Puffer now, we don't need a ton of compute to be running all these experiments, which is the cool thing. We still need a little bit, and we need a little bit more than we have now. So I'm dealing with fixing that. I'm going to be fixing that pretty soon. But yeah. Where does this get used? Values mean. We get B values mean. Right? So how then does this get messed up? And something's clearly very wrong. So we debug this. New value mean, new value std. And a reward block, right? B reward block. Oh, hang on. I think I see it. Wait, reward block, mask block. Advantages. Reward block. Ooh. Isn't this it right here? Isn't this of IDXs? Or is it not? Wait, reward block. Mask block. Hang on. Oh, it probably gets copied as Y, right? Yeah, hang on. It probably just gets copied. So how do I do this then? Let me try something else. Maybe if I do it this way. I times horizon. No, this still doesn't work. No point in even trying that. And that's rough. I do this. Does this do anything? Missing horizon. Maybe we don't have a straight up bug yet. But it is suspicious. It is suspicious. We shall see. Okay. This is something. Hello? Oh, wrong one. So it's still screwy, huh? Unless it's going to just solve it right now, but I don't think so. So there's, I guess to explain what's happening here, the algorithm has a horizon parameter. It performs it should strictly perform better with longer horizon. It performs pretty much way worse with larger horizon. And like setting it to longer horizon, but then nulling out the effect of what should be happening with the extra time steps doesn't help. So essentially, something is broken about the way that it is. Something's just fundamentally broken about the implementation, and I'm trying to figure out what. Mask block. Word block, mask block. Uh-huh. I've checked this portion of the code to death, haven't I? B values, flat, turns. You pass these in, nicely sorted already. Void block and mask block get passed in. Unless I have this wrong. I wonder if this is wrong. Let me think. This could be wrong, couldn't it? Wait, where's BPT horizon here? Dot reshape. Uh-oh. Okay, you use this in a flat output here. This could be it, right? That you have this messed up. We use returns advantages. Free shape. No mini batches. Mini batch size. It's tough to know, like, it's tough when you don't know for sure. Why does this even need to be reshaped again? Batch rows, no mini batches. It seems weird to me that that you even need that transpose, doesn't it? We can just look at these. We might be able to get something just out of this. Let's take Neptune off. Slows us down. Fiddly debugging. Fiddly debugging. Okay, this one is the same. And these are the same. I'm trying to think what else it would be, though. Hang on, maybe we need to look a little bit more closely. Okay. Let's try this. Put Neptune back on as well. That should definitely compute the same thing as before. I'm gonna have to remember to just take that out immediately so I don't forget. It's a little silly. The notifications just keep rolling on these. That's crazy. Yeah, but Atari 100K was just a god-awful benchmark. Okay, this is maybe something. Okay, maybe this actually works. Yeah, okay, so this actually works. Interesting. So it is the fact that you're using the additional data that screws you up, provided that this makes sense. Use the restroom, I'll be right back, and then we'll think about what that means. Oops. There's a little hiccup at the end of the training there, but that's way closer. So it is legitimately that including the extra data somehow messes you up. Hey, I can deal with that. At least there's a target to hit. DX. Oh, hang on. Is this what you want? I think this is what you want. Didn't you just completely clip this wrong? I think you just massively screwed up your clipping factor. Vantage scale. V max. Why would you do that? Oh, I think it's because, hang on. Yeah, no, I think you just messed up the way that you were trying to weight this thing, didn't you? So let me look at this. Hold on. Value standard deviation. advantage scale. Hang on. Max minus standard deviation over delta. How does that make sense? You just do this one, right? And then, I mean, if anything, you're supposed to clip later on. Hang on, let's run this and see what happens now. I remember what I was trying to do with this, but I don't think I actually implemented it correctly. Holy, these just notifications just keep going. Yeah, I'm updating my take on this following the responses to this. The thing that makes me now more suspicious of LLMs is the types of comments I get from people that are clearly using them heavily. Holy hell. Clear some of these out. I mean, it was a comment more about programming in general. It's just like you get better at programming and you understand how to solve more problems by getting closer to the hardware, not by like pretending it doesn't exist and programming in English. That's not even a phrase that makes sense. It's like, yeah, eventually I can do all the programming and everything else. But that doesn't mean that, like, oh yeah, now we do whatever. It's like, no, you have no added value whatsoever. It's like you're bragging that you didn't learn anything, and now you can do something that previously took training worse than somebody who's trained at it. Congratulations. You're basically bragging that you're lazy and you don't want to learn anything. All right, here we are. Okay, so we can cut this norm factor out, I guess. I don't know what I was trying to do with this, but it doesn't really make sense, whatever it is. I think it was like legacy, honestly, from when I had. Let me see. Values mean. Yeah, this must have been legacy. I think the issue is was with this scale, wasn't it? Minus V standard deviation. Wait, VSTD max. Oh, of course. Of course I get bitten for, like, of course I get penalized for this. Frickin' LLM. The one time I actually tried to just translate a piece of code, not even to write new code, just to translate code, I get dinged for it, of course. Serves me right. What I was trying to do originally here V standard deviation minus buff. I think here. Yeah, this is going to be a very unstable sort of situation, isn't it? Maybe not. Okay, let me think about how we normalize this, because this is all in the norm now. You have a distribution. Does this need to be normed to 1? It would seem weird to normalize this to 1. How weird is it if you norm it to 1? Not that weird, actually. I think we could try it. Subtract the min, then you divide by the max minus the min, right? But that doesn't penalize uncertainty either. Why can't this just be VSTD minus VSTD min over delta? Like, is there a problem with this? Oops, what happened here? Oh, yeah, this totally works, right? Except that you have wait, you have it backwards here, so it's gotta be. Yeah, it's gotta be like this. Max minus min. So you subtract the min, you divide by this delta, so you linearize. You just linearize this, and then you divide is that they sum to 1. We'll see how that plays out. CUDA error. Device side assert. Lovely. Probability contains inf or nan. Subtract min, divide by delta. By advantage sum. Lovely. Halfway decent engineer. I was like, what the hell? Halfway decent engineer? What the hell do you see me deving right here? I have to deal with CUDA errors, which is always fun. It's probably all in just this advantage scale thing. I wouldn't be surprised. We'll have to do a little bit of separate normalization on the other part of the value function, but we'll be fine otherwise. Still, yeah, CUDA error. Lovely. All right, what's going to nan or inf or whatever here? Max minus min. BSTD minus I don't understand what it would be that would be out of bounds here. I mean, it's got to be this sum is 0, right? But that's sketchy as hell. Okay, so it is this thing somehow being 0, which is means that this thing somehow has to be this thing somehow has to be 0. Crazy that that actually kind of learns. Yeah, I think we want to just subtract not the overall min. Vantage scale. I think we want to do this a little differently. STD min. About to make an order for personal machine. Well, I know that I ordered my machine a long time ago and haven't gotten it yet. So I would check on how long it takes them to get you the machine. I haven't heard anything specifically on the power cable issues, but yeah, I think it's still an issue. Eight to 12 weeks, crazy. Yeah, I don't know what we're gonna do with compute, with the mess that this thing's been in. I mean, I don't think I should have just like ordered all the machines like day one without testing to see if they even work. That would have been a nightmare, but takes a while. Okay, so we compute this. Okay. Try this. Whoops, that has to be deleted. T? Why did I do T? Let's forget the trailing comma in this. Right, there we go. So now this is going to be normalized to the individual row. That will give you a lot more stable time step-wise estimate. I don't think it messes anything up. We'll see. $138 likes on the tweet from today on Pokemon. Not bad for the day 2 one. So that's another 4,000 some odd views. We're doing good advertising for Pokemon. Okay. Still runs 782. Now what? I should be able to get rid of this term, right? That'll tell me something if this still crashes. Yeah, so this should not change perf very much at all. If it even has any effect, it really shouldn't do anything. But the fact that the kernel was crashing before was an issue. This should now be reasonably correct. Yeah, it looks nice. Okay. Now, is this enough? I mean, we now have linearized. We have linearized advantages. So, I mean, we should, in theory, just be able to set this back to horizon, 128 steps, and it should work. Theory. And if not, we'll have to look at why. But yeah, these latest graphs are, do we have any graphs on this, or is this offline? Okay, I didn't log in Neptune, but this will be reasonable. Now, mind you, that when we change the algorithm at all, it's optimized for a specific set of hyperparameters, so little perf dip is kind of okay if we think it's going to make it more robust, because we can always retune. Big perf dip should not really happen. There we go. Yeah, and it solves anyways, there you go. Basically solves. 840. Next will be horizon. Now, presumably this screws stuff up, right? Because it always does. But now we at least have some way of looking at what's getting screwed up and why. All right. Yeah, so this is, again, way worse. I am curious to see if it's going to line up with the previous curves, though, or if there will at least be some difference. I'll be right back while this runs. .400 score. Just in time to see 400 score. Very much in line with the previous. Okay. a little better, probably not statistically significant. Statistically. What's in buffer? Buffer contains the advantage scales, doesn't it? Buffer contains advantage scales. So if I just go here, where's this thing? No, it's P30 should work. It should work the same or better if you increase the horizon. And there's something screwy with the way that I have it set up that it doesn't. So I think that I'm going to be able to make the algorithm much better, but I have to, it relies on me being able to figure out this thing. Okay, so there is what is in buff. That doesn't look right to me. Does that look right to you? Not at all. 0.5. Standard deviation's all 1. But how's that work? Value standard deviation minus the min. Oops. No zeros in here, right? It's 1. So that ought to be, that ought to be just 1. Why does it contain 0.5s? What the heck is this 0.5? What is delta? What's delta in here? Delta is max minus min. There's no log in CUDA, is there? Minus min over delta. Delta equals 0. You don't modify the buffer anymore, though, do you? Seven, 126, 125. And that seems kind of weird to me, doesn't it? 126, 125. Oh no, it doesn't. This is fine. Why in the heck? Oh, hold on. Did I mess something up here? Because if you divide it by... The delta would still be 1, though, right? Noxious. Yeah, it's all ones. Buffer is equal to advantage scale. Hang on, that last one is a clue, isn't it? Duns. Ah, okay. So... Yeah, you have the done at the end there. Okay, so you get the standard deviations. You go up to 127. You set it to advantage scale over delta, which is max minus min. I mean, that's gonna either, that's gonna be 1. Delta is 1. Yeah, I don't see how this gets to be 0.5 instead of 2. I don't have to put this. Hang on, B. Standard deviation. Okay, well this is gonna drive me insane. I'm gonna just try some stuff so that we don't spend forever on this. I don't see anything wrong with this code. I'm getting kind of tired. One E10. Ah, lovely. You did this. That's a major error. I'm surprised it worked at all. Okay, so now this is all ones. Except for the 0 where it's not applicable, right? Perfect, and then you're dividing by sum. Okay. Now, interesting that they all went down by the same amount. There might need to be some symmetry breaking here. But then what happened to buff? That's all over the place, isn't it? Value standard deviation of index. Delta is equal to 0. Yeah, but none of this modifies the buffer. The only place the buffer gets modified is right there at the start. It's min divided by delta. Okay, the values means all different, but that shouldn't matter, right? Buff, 0. This isn't even 32 elements. There's 16 elements. How does that make any sense? This is 32 elements. So how'd this happen? Maybe it didn't get set. Or maybe you didn't zero it. It wouldn't make sense for you not just to have not zeroed it, like that would just leave ones in it. It's the min divided by delta. That's very weird. That's very, very weird. So many questions. Second epoch. First of all, the values are all the same for some reason still. Second of all, scale still 0. It should be like 1. Unless done's different. Hold on, maybe done's is off. Ah, wait, maybe that's what it is. Hang on. Okay, so there's your done stop. This. "16 steps in. So that's why you only have 16 values, so that's fine. But then the values themselves, the advantage scale. Yeah, that doesn't make any sense to me. Not overwriting it or anything, right? Very weird. Okay. We're gonna start this shenanigans again. You can't do breakpoints in CUDA, right? Is there CUDA GDB? Can you just install this thing and hang on? Okay, so yeah, that changes it a lot. So there's like some noise or something here, I think. Yeah, there's some like very slight noise thing going on here. Let me see if this works. Oh, this does work. I see. So if I wanted to go through this, I'd actually have to like write a CUDA test or something, which is a little annoying with the way that this is bound to Python. Okay. But the fact that there's like a very slight difference here, and I think it's getting accentuated or something. But this is kind of an extreme case. Like hang on, why is this even happening in the first place here? Value function should not be subject to this, right? Maybe I just give it a couple continues first. so this is what we get at a buff. Oh, there is a symmetry problem. That's really weird. Give it a few more of these. Oh no, okay, it's just, it takes it a second. So if we look at this now, okay, you do have this backwards. So you want to subtract the max. I think it's going to take us right back to where we started, to be honest. Not quite. We have better stats, at least. Congrats on the Pokemon Red achievement. Thank you. Yeah, it's the result we've been looking at for a while. We wanted to get rid of all the scripts. I mean, really, that guy's been the lead of it, or I guess David now. That guy in the Discord. We wanted to get rid of all the scripts, and I think we could have still gotten rid of more of the scripts than we currently have in there. But at some point, you just have to run a lot of experiments. And Pokemon is nowhere near as fast as all the other M's that we're making in Puffer, since it's an existing game. That's tough. Like, literally, if you were to just write, if you just had Pokemon not running through an emulator, just like the same thing, just not written for an emulator, it would be, the project would have been much easier to get results on faster. It's just a pure speed limitation. But still, I mean, it changes the way I think about RL a little bit, knowing that that is a possibility. Okay, so this is negative. We can just make this, we can just do this one, and that'll fix it. This will fix it. There's so many cool GIFs here to post. That's funny. Okay. 11.66. 11.98 is 0 somehow. What? Oh, that's something right there. Okay. So this first bit, 2, 3 is a segment. 0.3 and then O. Okay. And then what happened here? Wait, actually, what happened here? I don't have a 32 in here anywhere, do I? No. Experience.buff. Oh, okay. It's because this doesn't, the rest doesn't get trained. Yeah, so that'll totally mess it up. Let's do, let's undo that for now. Huh? Why is the value standard deviation? Well, that's weird as hell. Yeah, definitely something wrong with this. Probably this loss, right? Maybe this is different. Oops. Is this optimizing backwards or something? Something's weird. Yeah, okay, so this mask block is not getting, I mean, nothing. I think you forgot to zero it, right? Mask block. Okay, I don't know about the 1.0 at the end like this. But that's closer. Oh, maybe it is. No, maybe it is. Still not handling this portion correctly, I don't think. Just a buff. Divide by advantage sum. Subtract the max. Subtracted the max, right? What was the max? 15. Problem is that the difference is very small. Hmm. Mm-hmm. Yeah, this is getting very diluted here. It gets very diluted. I'm not quite sure how you deal with this sort of a thing. If you initialize standard deviation to 1, When does a point stop mattering? Not a huge fan of the way this is working. I mean, this is just going to be a lot of thinking work. Is there an existing thing that you can throw at this? I don't think so. Values. I mean, the standard deviation of your prediction, if you know it perfectly, is 0, right? If you subtract the largest of these values, that's a great way to check the baseline of it. I mean, maybe these get more consistent if you let it run a little longer. So now we have this one for values. Okay. I mean, that's something, right? Is there a 1 in there? Oh yeah, no, it's just gonna give me these. Those are some weights. You don't necessarily want to subtract the min there though, do you? Maybe you want to subtract the global max. If I do this, does it fix the problem? If I replace this with the global max. Well, this isn't going to help me because yeah, this doesn't get trained the way this is. The segments happen to line up like this. Okay, I could modify the signature, right? Yeah, I'm kind of just getting tired here. I know what I think I need to do. I want to 0, 1 normalize this. Hang on. The row max. I has to also return. Has to return that as well, doesn't it? gosh, frickin' pie bind. Does this do anything? How do you return this stupid thing? You can't even do this, can you? Okay. That's what you're gonna do. I'm gonna do this one. Okay. I'm gonna pass in a max, but it's gonna be a little different from this. Okay. 1.0. Kaboom. What is this bullshit? Very fiddly. Very, very fiddly. All right. Finally. We're getting somewhere, potentially. Lovely. Going a little bit more. Yay, we get something. Not bad. And then what do we do? Do we clip this? Do we clip this? Or what? Zero to 0.1 maybe? Yeah, that's a clip. Okay. Let's see if this does anything. And then the question would be, what do you actually initialize this thing to? We just stuck? No, we do something. It's in the compute? What do you mean? The issue is, oh, compute advantages. Yeah, the issue is, I think it's just the way that we are. When you expand the horizon to 128 elements, there's a little bit of noise. And if you don't account for that noise, then you kind of just smear your credit assignment. I mean, we've got to be able to do something better than this, I would imagine, but. Where'd this run go? Didn't I have, yeah, here it is. Now, this wasn't what I was looking at, is it? Maybe it was. No big boost at the end, huh? Oh, kind of. Ugh. Still causing issues. Just, this is kind of ridiculous, but let's just clamp to 20. I actually wonder what, hang on. Lose 2/3. 0.99. Are you kidding me? What's with this device side shenanigans? Nothing's greater than 0.2. Yep. NetHack is good. Lots of Pokemon as well. Hey, Ryan. We're working on the new algorithm. It's a pain in the ass. New algorithm. I think I'm going to be able to beat PPO, but it's kind of hard. Wait, if you just do this division by advantage sum here, right? Maybe we do this instead. What's this? What is this that you linked to me? C3B. This image doesn't load, but I see from the URL. I was thinking about 3PO, but I don't know. Not really a Star Wars kind of guy. I am currently stuck fiddling with CUDA kernel for this new algorithm. What is the difference from PPO? Long horizon variational value function and a different advantage function. And it cuts two hyperparameters out of PPO, no more gamma and lambda. So if it works, and I get it to work well, it's very big. And I actually do kind of already have it matching on breakout, very, very close to matching perf on breakout. But there are a couple of quirks I need to fix. My Twitter feed is just blowing up repeatedly. Gamma-free stuff from continual learning. Do they have anything that actually works that I should look at? Because I have something that seems to actually work. I'm testing PPO and continual M's. What is a continual M? That has no relation, though, whatsoever to whether you need gamma or lambda. Okay, so this didn't help. Back to this. I'm gonna have to think about this. That's kind of funny that they invented a whole branch of RL for like non-episodic. It's the same damn thing. Really don't like the way that I'm doing the clipping here. I mean, I assume that this is probably the main issue. Let me think, does that make sense? Does it make sense for this to be the main issue? No point weirdness. That seems like an entirely academic distinction. Average reward. Yeah, I pretty much don't have any idea what they're doing there. I have very, very little confidence in that line of work, just because of how it's framed, because it doesn't seem to be framed correctly. Standard RL methods don't work well in these M's. I've been doing, I mean, neural MMO doesn't exactly reset either. Like, there's really no difference. Yeah, well, everything's gonna forget unless you have a replay buffer, and then it won't, right? I don't know. I've kind of been relying less and less on the literature in RL because, like, most of it is poorly motivated, and most of what is correctly motivated is wrong. Like, I keep finding so many errors and stuff that it's just like I've completely lost confidence in the accuracy of basically every publication. I don't think what I do with this. Big claims. Sometimes there isn't even new knowledge, though, is the thing, because it's like, it's not underneath there's new knowledge. It's you have to do an additional 3 papers worth of work that they didn't do of ablations in order to see if their thing actually works. Like, you're tuning graduate students to environments for the most part. Yeah. But the thing is, the legwork is the hard part, right? Coming up with pretty sounding ideas is not contribution. Man, this is very weird because, like, right here, I wonder what happens if I run this with the original 32 Horizon. Does it work? Does it work again? The thing that's just tricky here is, like, I have this thing working when you specify a short horizon. It should work identically or better with a long horizon, but, like, you kind of need to you need to smooth out the noise in your predictions when you do that. Otherwise, you just smear all the credit assignment. Use some of that legwork. Well, yeah, but the issue there is mainly just that the env is like 100x slower than the other M's in PufferL, so we can run 100x fewer experiments on the same hardware. That's the main issue. I mean, literally, more than anything you could do on the science side, like, the best thing you could do for Pokemon would just be rewriting the game off an emulator. Like, without the emulator, get it to be 100x faster, and then it would just be easy. If I don't get booted. Hey, I mean, drop in the Discord. We would very much appreciate that. We are going to try to get our own compute soon as well. It's just there are long lead times on the 5090s, and I need to make sure they don't catch on fire. And we'll get the popper cluster. Do you think Pokemon experiments can finish in 3 days? Probably not. Actually, definitely not with 8 CPUs. Um, up to a week on our machines. which are at least 3x faster than your machines. It's a pain in the ass. Shorter ablations, yeah. How do you do this? It's very weird. Clusters aren't good for long experiments, but we have puffer hardware for. Leave you to it. I owe them a review. Pick them on paper. Yeah, that'd be good. Thank you for that. Man, I'm like so annoyed with this. I'm trying to think what the hell it even is. What the hell is even the problem here? Like, this does seem reasonable to me. So why is this not good? Sorry. Gosh. Neptune. What the hell is wrong with this? Fuck. Hello? Somehow just crashed. I guess if you just kill it halfway through, just crashes. Ridiculous. Come on, get to 10 mil. That looks not bad to me. Hang on, wait a second. Does this... doesn't make sense. Why is that 0.5 and not 1? Yeah, something's definitely screwy. And then do you want it to be clipped like this? Or do you want to like subtract? delta will be. So fiddly. There's got to be something simple I can do for this scaling. Hang on, maybe I can do. I've got to be massively overcomplicating this. There's just got to be a way simpler way I can normalize this. What's this frickin' paper? What is this paper? This is the Sutton paper that doesn't make any bloody sense, right? Active 50,000. Apparently the appendix for this actually has experiments. I'll look at this paper more, but I have no confidence in that. Come on. You have standard deviation. It's going to be scaled differently. So it is the scale of the standard deviation that is off, right? What if you were to just center the standard deviation? Can you do that? Can you do that? I don't think so. They're gonna drive me nuts. I doubt I'm getting anything out of Grok, but I'm out of ideas for now. Can I do, wait. Wait. Can I just do Gaussian? Gaussian negative log likelihood. Maybe it's just this. That would be kind of silly, wouldn't it? It's const. But minus target. Well, you can't square it. Divide by the variance. Hang on. Isn't it just, it's 1 over it, right? Or 1 minus, like, targets are treated from samples as samples from a Gaussian distribution. Constant term is omitted unless full is true. Do reward minus quantity. It's just one, yeah, so this is what I was looking at before. You could square this, gives you variance. It's only 4x or whatever. You'd subtract out the you can't subtract the min here anymore. Can divide. Does that help though? No, it doesn't help. It's a thinking day. Today is a thinking day. 34. And the issue is that, like, standard deviation of these predictions. Checked. This is massively irritating. Maybe I haven't thought about the advantage function well enough. Problem is, there's like, if you just predict randomly, there's a certain standard deviation you're going to have from that. It's not randomly, it's to predict majority, I guess. All right, well, I have a meeting in a few. Um, yeah, this is hard. I'm gonna really have to think about how I deal with the advantage function for this. This is just gonna be like a thinking problem. Um, yeah, that's all there is to it. I mean, I know I have a version that works at 32, so we just have to think about how that's set up and what I can do on top of that. All right. Yeah, I will be back later tonight or tomorrow. We'll see. Thank you, and yeah, check out puffer.ai for more. But it's gonna be kind of slow until I figure out this algorithm.